So we're starting with another topic from Unit 1, and that's concrete. Okay, this particular chapter will have following contents. First, we will start with the introduction, then the properties of concrete, ingredients, grades of concrete, and what is water cement ratio. In brief, we will discuss manufacturing of concrete, and then we will end with special concretes. Okay, so now what is concrete? Concrete is a homogeneous mixture. What do you mean by homogeneous? Homogeneous meaning wherein all the ingredients should be seen together. You should not find one ingredient in one place, other in the other place, right? It will be well mixed, okay, very evenly mixed. So it's a mixture of binding material which binds on the other ingredients. Now these binding materials can be cement, it can be lime, anything that is cementitious that can bind together. Nowadays, people add cement with fly ash, cement can be mixed with GGBS, sometimes cement. There are various other cementitious materials can be used, but when I say primarily concrete, the first idea that comes to your mind is something which is mixed with cement or lime. Okay. Then, with cement or with the binding material, we have fine aggregates. Fine aggregates, primarily aggregates are what? Aggregates are inert materials. See, when you make concrete, you have cement, fine aggregates, coarse aggregates, water. Admixtures are materials which alter the properties of concrete when it is in wet state or when it is in hard state. Now, these fine aggregates and coarse aggregates together form something called aggregates. Now, what are these aggregates? These are materials which are not reacting, inert materials. So, if you have seen concrete, when you mix, it is like a paste, right? It's in wet form when you make concrete. So you have cement mixed with sand, and aggregates are what we call metal. In local terms, we call it khadi. Okay, so this khadi and sand and cement, when you mix it with water, it will start binding. It will start making. It will start setting. It will start hardening. So why is it hardening? Because the reaction is occurring between cement and water. What about sand and coarse aggregates, gravel? They do not participate in this reaction. They are the inert people. They are only there to impart strength, impart hardness, impart durability. Okay, to a certain extent, they are also fillers, because just cement and water will be very costly, right? So to a certain extent, they are doing the job of inert fillers. Okay? And then admixtures are these chemicals which will alter the properties of this concrete. So let's say when you start adding water in a matter of initial setting time, final setting time, we have already studied when we did cement, right? Which studied cement as a material. So after 30 minutes, if it starts setting, then by the time it hardens, let's say you want it to harden very quickly, or you want to harden it very slowly, okay, because you are transporting your made concrete in, let's say, your RMC plant, ready mixed concrete plant, which is, let's say, at Ponda and your site is at Margao. You want to delay the setting, then also you get something called retarders. You want to accelerate setting, you want to make it fast, because let's say you're using concrete in highways. You want the highways to be open for the local traffic. So you will go for something which is very quickly hardening, rapid hardening one. So then in that case you can use accelerators. In some places concrete is also used only for architectural works. Something like you want to make a parapet, or you want to make a balustrade, or you want to make anything which is not going to take load. Okay, in which case you don't need strength. In fact, in such cases, you are not using it to put any pressure on it. You are not going to load or anything on that concrete. So in that case, you can go for air entraining admixtures, which will create bubbles inside, so that your block may become lightweight. There are multiple different types of admixtures. We will deal with all the ingredients in detail. Now, what makes concrete so special as building material? The first thing is it can be molded into durable structural items. Okay, you can make columns of whatever dimensions you want. Okay, what is the other alternative to concrete? You must have seen beams and columns made out of steel. Now, which is better? Obviously, steel will be costlier and steel will be stronger. But steel is not available in all the sections that you want. Steel has corrosion issues. Okay. Now, what are the other building materials you have studied? Let's say you have studied bricks. Can we go for concrete in place of bricks? Concrete can be made of whatever strength you want, right? So, bricks, what happens? It depends on the raw materials. Obviously, concrete also depends on the raw materials. But the range in which you will get the properties is way larger than what as compared to bricks. It is way more durable. It is more water resistance, right? It has better life than bricks. Similarly, whatever is applicable for bricks is also applicable for laterites or any other stone. Concrete is non-porous. It doesn't allow water to go inside. That's why it is very strong. Then you can combine it with other materials, like say you know what is RCC, reinforced concrete cement, reinforced cement concrete, sorry. So you have steel embedded inside the concrete that makes it RCC. Now what happens when you add steel? So wherever you see, concrete is primarily good in compression. It's not as good in tension. So whichever part of the structural member that is made out of concrete, let's say you're making concrete in a beam, you're pouring concrete in a beam, the lower part of the beam will be under tension. In that case, we reinforce it with a material which will be good in tension. Right? So, you will see steel bars in the lower part of the beam. You do see them on top also because you need to provide nominal reinforcement on the top also. There are IS codes which tell us how exactly detailing is to be done. That we will know in depth in the fifth semester. However, so what happens with this concrete as building material is wherever it is weak, it is possible to add some other material and make a composite material which will give you a good property. So it's possible to control the properties of concrete. So you can make it more stronger, you can make it weaker, you can make it aerated, you can make it slender in size, whatever you want. Okay? It's possible to mechanize completely its preparation and placing processes. So earlier people used to mix it with powder and all that. Now then started these mixers, concrete mixers. Now you have RMC. Concrete is mixed in a factory and it is just brought to your site and then pumped. You just pump it to the place where you want it to be placed. Right? So it's possible to completely mechanize it. Now what is the advantage of completely mechanizing it is when you mechanize something, the errors because of human interference. Sometimes when, see, finally who's going to mix it on the site? It's the labor class people who are going to mix it on the site. They should understand which ingredients, how much water has to be added, and they should understand the importance of it. It's very difficult to make them understand that no, you are not supposed to add so much water. If you go to any site which is not being supervised by engineer, you will see the concrete will be in a very thin consistency. Because you do not understand that water can have a lot of catastrophic effects on concrete, right? So that's the reason when you mechanize something, those kind of errors due to poor workmanship, poor handling, okay, can be eliminated. It possesses adequate plasticity for mechanical working. So it is in the consistency is so good enough that it can be easily pumped, right? So going ahead, what are the properties of cement concrete? First, it has very high compressive strength. It is free from corrosion. There was a catwalk. You know what is catwalk? Catwalk is a small bridge. Okay, very small bridge, actually meant for only pedestrian traffic. There was a catwalk being constructed here only in Goa in MPT Harbour. 3 catwalks were constructed in steel. They constructed one corroded fender, second one again in steel, corroded fender. Now, why is it falling down? Because Vasco is a port, right? They were constructing it in water actually. It was not even offshore, in the water. So, because when the ships used to anchor, for people to move from the one dolphin to another, what is a dolphin? Dolphin is a group of piles. So what you have is, you will have a concrete pile cap, okay, and then there were piles. Okay, I don't know whether you all are aware of piles. We have covered foundation if I'm mistaken. Piles are these concrete columns sort of things, but they are used for foundation. So if this was ground level and this was your water level, then what these dolphins, they are actually structures which are constructed in the waters to anchor huge ships. So you have them away from the shore. So you'll have multiple such dolphins. Okay, you'll have multiple such dolphins, and then you have the ship's anchor. Okay, now if you want to navigate between the two dolphins, there were catwalks constructed. Okay, there were catwalks constructed. So now this catwalk will be nothing like just like a slab, and this slab will be directly resting over the pile group. So there were two piles on, and there was a pile cap. Okay, on these two piles there was a pile cap, and over the pile cap this catwalk would be resting. Okay, so this was something like this, and the standing height of the water was somewhere around 3 meters, and the distance between the two dolphins was, if I'm not mistaken, somewhere around 20 meters. So initially they had constructed this pedestrian bridge of steel. They constructed one, it collapsed because of the road. They constructed second, that also collapsed. Then they went for RCC. Why? Why did they go for RCC? Because of this. Because this is free from corrosion. It's also cheaper, but it is also free from corrosion. Then it hardens. Now that catwalk which was constructed is still there. There is nothing wrong with that catwalk. Then it hardens with age. These are some unique properties of certain materials. As the days go by, the material becomes stronger and stronger. Another material which hardens with age, can you give me an example? Laterite hardens with age. Soil becomes stronger with age. Okay, it's proved to be more economical than steel. It rapidly binds with steel. It has tendency to shrink. Is it a good thing or a bad thing? Sometimes it's good, sometimes it's bad. Because of shrinking, cracks can occur. Okay, so it can be bad also at times. It has a tendency to be porous. This is certainly bad. Okay, it forms a hard surface capable of resisting abrasion. Okay, its quality is much dependent on the site condition. This is one issue because of which sometimes we prefer steel section than RCC sections. Why? Because you need good supervision. If someone just unknowingly pours water in, the cement consumption quantity alters, then everything, final property of the cement concrete can alter. So it requires good supervision. Okay. Now let's go to the ingredients in detail. Now, cement, we have already studied what is cement in depth. So I will quickly rush through this. Okay, what is cement? It's the most important ingredient. Okay, and the most expensive ingredient also in concrete. It's produced by burning at high temperatures, intermixtures of calcareous, siliceous and aluminous substances, and grinding the same to a very fine powder. It's available in the market in the bags of 50, common brands ACC, Birla, Ultratech, etc. Then we have fine aggregates. Now, what is fine aggregates? What is fine aggregate is this. Please don't say when I say what is fine aggregate, it is sand. No, that is not the thing. Because sand is not available everywhere. Sand is available in Goa. Will sand be available in Kashmir? Will sand be available in the interior parts of the continent? Obviously not, right? So what is fine aggregate? Fine aggregate is the material which is less than 4.75 mm. This is a very important figure. You should remember this, okay? And natural sand is commonly used in concrete. Stone dust is also used. What is stone dust? Now what we call it as M sand. That is also used. What is M sand? Is basically manufactured sand. You have stones being crushed in sizes which are less than 4.75. That is called M sand. It should not contain more than 10% of the fine particles. That is governed by code. Okay, we will go to M sand in depth in the next video.